Hello everyone. In the last video, we discussed the basic functions that help us make a heap in Go. But do you know that there is a package called container/heap which provides a structure for working with heaps in Go? If you observed in the last video, we had used functions like less, len, and swap to build the heapify functions. When we use container/heap package, these are the ones that we need to implement if we need to make any type behave like a heap. In other words, the container/heap package provides an interface or a contract that any type needs to implement or follow for it to behave like a heap. Apart from these three, the interface also includes pop and push functions, which, as the name suggests, are used to pop an element from the heap and push an element into the heap respectively. Notice that these two functions are defined on the pointer to the MaxHeap type and not on the type itself. Let's try to make a heap using these functions. In the first step, we define our own type MaxHeap, under which we use a slice. The keyword type in Go is used to declare a new type. But why do we need a new type? Why can't we just use the integer slice itself? Well, this is because the custom methods that we want on a type, which are less, swap, len, pop, and push, we can't define them on a built-in data type in Go like a slice. They should be defined on a custom data type, hence the first step is to define a type. In the second step, we define all the methods one by one. The len function returns the length of the current heap. So here we return the length of the h directly because the underlying type is a slice. The less function takes two integers which are indices of two nodes. It returns a bool indicating if element I is less than j or not. For min heap, h of I should be less than h of j. For a max heap, it should be the reverse. And the swap function should just swap the values at I and j. The push function accepts a value of type interface and we need to add it at the end of the array. Why at the end? Because when we add any element in a heap, we always add it at the end. The pop function should return the root of the heap, for which we first store the last element, then we reduce the size of the underlying array and return the stored element. Go internally takes care of the structure of the heap. Now, there should be questions here because I know I had a few. For instance, what is this before the function definition? What is this interface and why have we used the int like this? Isn't there a better way? And why do we remove the last element from the heap when popping is nothing but taking the first element and returning it? Let's tackle them one by one. So what is this before the function declaration? Well, this is nothing but a way of declaring a function on a particular type in Go. In object-oriented programming languages like Java and C#, we can define functions inside a class, and one way of calling those functions is to have the type of that object dot the function name with all the required parameters. Well, Go doesn't have that. So we define a function like this if we want to call a function on a particular type. But what is this empty interface? This empty interface resembles the type any in TypeScript or class object in Java or C#. We can assign any value to it. That's why when we use it, we can pass any value of any type to the function. To get the original value with the original type back, we use type assertion on the interface variable. Here, we are asserting if x is of type int or not. If yes, the integer is returned and is appended to the array. If no, we get a runtime panic which can be caught using the defer panic pattern like this. Or if you want to be safe while asserting a type, which you should try to be, you can use the result OK pattern in Go. This pattern is used in many inbuilt functions in Go and returns OK to be false if there is a panic in the performed operation and we can handle it in any way we want. There is actually a better way to define the push and pop function without the empty interface. So we don't have to use the unboxing and boxing of variables when we pass or use them. It is through generics which was added in 1.18 version of Go. But they are outside the scope of this video. Definitely subscribe and leave a comment if you want to see it in future videos. Also, the differ, panic and recover pattern will also be discussed in a greater detail in a later video, which makes it a pretty good deal to subscribe. Alright, now the main question. Why do we remove the last element from the heap when popping is nothing but taking the first element and returning it? Well, that's because when we call the pop function, we don't directly call the pop function on our definition of the heap. We do it through the heap object provided to us by the container/heap package like this, where we pass the pointer to our heap. Here, Go internally first swaps the root with the last element, gives us the last element using our pop function, and then performs the heapify down on the root to restore the heap property. And all we need to do is to remove the last element. Now how do we use the heap? Step 1 is to declare the variable of type MaxHeap or a pointer to the MaxHeap. We'll use the pointer to the MaxHeap because it's much easier. Then in the step 2, if we already have an integer array nums, we can either loop through the entire array and push each element one by one, but we know that this will take O of n log n time from this video. Or we can directly typecast the pointer to the given array to a pointer to a MaxHeap type like this. We have to call the init function from the heap object on our heap in both the cases, which is step 3. This function builds the heap from our given array, and implementation would be similar to the build heap function that we have already discussed in a previous video. And as we have already seen, to pop an element we use the pop function provided by the heap object. We need to pass the pointer to our heap array to the pop function. To use the push function, we use the push method provided by the heap object again. We need to pass the pointer to the heap along with the value that we need to add to the heap. So, the step 1 is to declare the heap. And we can use the step 2 and step 3 interchangeably, which are to initialize the heap or add elements. This depends on the nature of our input. If we get the array all at once, then we can add the elements first and then initialize the heap. And if we have an inflow of elements, then we can initialize the heap first and then add the elements. Well, that's all for the container/heap package provided by Go. Please leave a like if you learned something and subscribe to keep learning. Thank you.